Okay, so the last thing you guys should have on your notes were variations in temperature, right? All right, so let's talk about, this is going to be a continuation of yesterday's lesson on winds, okay? Here's the big thing. Everyone assumes that the way that winds are named is where they're going to. No, it's where they're coming from. So if they say it's a southwesterly wind, it means that the winds are coming from the southwest. Okay, so they're named from where they're coming from. So you guys are all watching the Weather Channel for 5 minutes a day, right? Hopefully. Okay, if you're not, please, especially for this unit, start to watch. All you need to watch is one time that they're doing the weather. That's it. When your parents are watching the news and the weather comes on, just kind of stop what you're doing, watch. And you're going to start to realize that you know more as time goes on. Question?
So you're saying that if it's a north wind, and if this is north, it's coming this way?
It's coming from here towards you, yeah. Even though you're technically south of where it came from, it would be a north wind. Okay? So, what causes the wind to actually blow around? Right? Well, it has everything to do with the unequal heating of the earth. Okay? We have an unequal heating of the earth. How do we know? Normally, in 2 weeks, a bunch of you guys, or at least a week and a half, would be heading south. Why? What is south of us?
Warm temperatures.
The equator, warmer temperatures. Florida. Some of you guys would go say hi to Mickey Mouse. Some of you guys would go to California or Texas. Some of you, or a lot of you, would end up in Mexico or the Caribbean, yes? Or you're like me and you're like, I just don't want to do work today for next week, right? You would do something, and most people would head south. Why? Because in the south right now, it is warm versus the 18 inches of snow that we have outside that'll probably be more by next week. Okay? So, there's an unequal heating of the earth, so it's based on the temperature. It's also based on the pressure differences in the atmosphere. Okay? So we have an unequal heating of the earth and pressure differences. So those two things that are combined are going to make the winds blow. Okay? Or move. All right? So like we were saying, what does it mean by the unequal heating of the earth? Well, we were just talking about it, right? All over the earth right now, we have different temperatures that are happening. In the southern hemisphere, it is their summer. Right? Even though, like I said, there's like 18 inches of snow outside. Right? You have to remember that warm air is going to rise up, cold air is going to sink down. Why? Because in warm air, they move more. The molecules that are there, they move more. Right? They increase their kinetic energy. When they increase their kinetic energy, they move apart from each other. When they move apart from each other, they become less dense. When they become less dense, they rise up. Right? So warmer air is going to rise up. Cooler air is going to sink down. So because there's an unequal heating, the wind is going to be moving depending on that. Because of this, it causes a difference in pressure, which then leads us to the wind. Okay? So you remember that pressure and temperature have an inverse relationship. Okay? That pressure is what causes the wind to blow. So the fact that we have a temperature change creates a pressure change, and that's going to change how the wind moves. Let me know when you're done. You guys at home, you okay?
Yeah.
Yep.
Okay, so what causes that unequal heating? Well, the fact that we're tilted. We know this. We have 4 seasons, right? Because we are tilted, and we stay tilted about 23.5 degrees all year long. Now remember, there is that little wobble that happens, but it's not so much so that it's going to change the tilt by too much, right? What that tells me is that the tropics, or right by the equator, they're going to get more direct insolation than that of the poles, right? Because at the poles, 6 months out of the year about, right, you're going to have 24 hours of daylight, and 6 months out of the year, you're going to be in 24 hours of darkness.
Get tired of you just dark all the time.
It's creepy, I will tell you. Let's see. Hey Siri, when was the last time that Alaska saw the sun? Let's see. So November 19th, 2020, the sun rose and set in Alaska for the last time for 2 months.
Wow.
Because of the angle and the tilt of the Earth, right? And the angle at which the sun is going to hit them. It wasn't going to hit them for 2 months. So they weren't going to see, the last time they saw the sun in 2020 was November 19th. And I also saw the sun January 22nd is what it's saying here. Let's see.
I didn't even think they were that far north.
They're far enough north.
Is that like in the area of like Greenland?
Might be the same latitude, double check that. Okay, January 22nd. They still haven't seen the sun. Yeah, they just saw the sun a little while ago, not very long, right? So for 2 months, they were in complete darkness. That means 2 months out of the year, they will be in complete daylight all the time for 2 months. All right? So all three of these things, including the shape of the Earth. So here's another way that we can prove that the Earth is not flat. Okay? If the Earth was flat, then every single place on Earth would see the sun the same amount. They would also not have wind because they would all be the same season at the same time, which we know is not true. Okay? So,
why don't they do so many experiments and they end up proving that the Earth is round, like by accident?
well, there's a cruise that the flat earthers are supposed to all take.
When?
It's supposed to happen in January. Don't know if it's still happening. So, isobars, guys, we already talked about it. You don't need to write it down. But isobars are basically the contour lines of a pressure map. You know this. We have isobars, isotherms, and contour lines, right? Simple. So here's a fact, though. Winds are going to cross over those isobars. Okay? Now, each one of those isobars are a pressure line. Okay? If each one of them are a pressure line, the wind should not be able to. However, okay, because we rotate, the winds are going to curve. How they curve is a different story. Oh. Okay, so, right, here we have a isobar map, right? This looks familiar. It looks just like a contour map, but it's not showing different, the lines are not different elevations. They are different pressures. Now, nowhere on here has the units. How am I going to find the units of pressure?
Well,
I don't know. Why is that? Just by looking at this map, guys, and I'll give you a hint, it's not kilometers. How am I going to know what units of pressure these are in?
Because it's wind.
Because it's wind, but where am I going to figure out? Or is this going to be kilopascals? Is this going to be atmospheres? Is this going to be inches of mercury? Is it going to be torr?
Is it the L?
By the
It's not the high or the low.
would it be by the contour lines?
What do you mean?
Like the ones that are like closest together are like the. I don't know how to exactly explain it, but I don't know.
So the ones that are closer together, what does that mean?
That the wind is like more, or like the weather in that area is more concentrated than away from it.
It's a little bit of both your answer. So you're saying it's a steeper gradient, you're saying it's more concentrated. Yes, the lines that are closer together means it's going to be much windier. So when you say steeper gradient per se, you would say, instead of saying it's steeper, you would say it would be higher wind. But look at the numbers here, guys. The numbers that are here start at 996 and go up to about 1040. Is there some place that we can look where I can figure out what units of pressure I'm looking at? Where on the reference table, which you all have out on your desk, right? Look it up, look it up, look it up. Where am I going to find the pressure on the reference table?
Page 13.
Right, page 13 on the right-hand side on your reference table, right? It's how we convert from millibars to inches of mercury. Does everybody see that?
Yeah.
Everybody else see that? Guys at home, do you have your reference tables out?
Repeat that, please.
Yes.
Reference table page 13.
Okay.
Okay, so if I was to choose between millibars and inches of mercury, which is this map in?
Millibars.
Why?
Because inches of mercury, it would be too high, whereas the millibars, it fits the range where it's state. The max is 1040, and that max is 1040.
Do you guys see that? Do you guys see that at home? That it would have to be millibars because of the numbers that are here. They go from 996 to 1040. If I was to think, oh, is this inches of mercury or millibars, right? This is millibars for that reason. Okay? Now, we would figure out gradients the exact same way, right? If I wanted to figure out the gradient between X and Y, I'm going to take the change in field value. So that's going to go from 1028 to 1,000 divided by the distance. That formula is on page 1 of your reference table. It's just gradient in general. You're just throwing pressure in front of it. It's the same formula from the topographic map. Okay? Remember, everything in earth science comes back and you end up building on top of it. Even stuff from the first week of school. Okay? So you're going to want to make sure that you still remember, especially for those of you who didn't do well on the midterm or, had a little help. Okay? You're going to want to make sure that you really know it because you're not going to be able to do that for the final. Okay, so how do isobars? You know this already. We've already talked about it. It's the same thing as contour maps. If the lines are closer together, it means that it's a higher gradient and the strongest winds. And it's the opposite for the lowest gradient. Don't have to copy it down because you already know it. If the lines are closer together, it's going to be the greatest gradient and the stronger wind. When they're further apart from each other, it's going to be the weakest gradient and the lighter the wind. All right, so what affects the wind direction? The first is going to be that Coriolis effect, right? If we're in the northern hemisphere, which way do the winds go? To the right or to the left? To the right. Everybody agree or disagree? Agree,
Agree.
right? There is this tool known as a weather vane. And I guarantee you my weather vane is cooler than yours. Okay? A weather vane is usually, you see them more than not on the top of a barn. In any movie, they're at the top of a barn and it has north, south, east, and west like this, right? And then on top of that, usually it's a rooster who's like,
Yeah.
right? You have one?
Yeah, it's
Awesome.
in my garage. Like I can see it through my window.
Oh, really? Is that a hair or something inside my mat? It's really bugging. Oh, wait. Okay. So yeah. So it's like this, and then the rooster who's sitting there, like, moves. Now, wherever it's pointing towards, it's pointing into the wind. So to answer your question from before, right? If it's pointing this way, that means it's a north wind coming at you. Right? So it's going to point towards where the wind is coming from. I still say mine is going to be cooler than yours.
Isn't it effect instead of effect from Coriolis?
Might be.
Because I remember it always being spelled as effect.
It might be a typo. So that's from everybody's. That's actually the picture, guys, for when we did the Coriolis Effect.
Oh,
You know, just a little flashback for you guys. But my weather vane is cooler than yours.
oh wow, that's
It's not actually mine. I found it on Halloween. I kind of want to buy it though, because it's Godzilla, and I just love Godzilla. Which, by the way, is anybody gonna watch Godzilla vs. Kong?
I am. My 6-year-old brother is freaking out.
I cannot wait. Okay, so this, well, it's got to be Godzilla.
Yeah, but
This-
Kong is like being sought out to be the victim.
Well, because they think it's not going to be Godzilla, they think it's going to be Mechagodzilla. That's why. That's the theory. Anyway, back to this. So this arrow is pointing in between north and west, so it's a northwesterly wind, right? Because it's going to come from the northwest. Yeah, it's supposed to be stomping on telephone poles. That's what I said. Mine is cooler than yours. I kind of want to buy it.
The movie is highly anticipated. Whoever's making the movie, they're pressured to make it very good.
I know. Well, you also have the geeks like me who've been watching it since they were like this big with their parents. So you've got like multi-generational. But anyway, back to this. So here's everybody's most hated reference table. Why? Because it's a ton of information, right? So far, we've talked about the Coriolis effect on here, and that's the dotted line, right? If you're standing in the north, looking north, it goes to your right. If you're standing in the north, looking south, it still goes to your right, right? It also always goes from the dry band to the wet band, because dry is just another way of saying high, and wet is just another way of saying low. So it always goes from high to low, and therefore it goes from the dry band to the wet band, okay? Then, it also leads into these convection currents, because the hotter the area, right, like the wet zone here known as the equator, right, it's going to make the air rise up and move down from there, right? But it always goes from for that part, from low to high. Okay, let's talk about those global wind patterns, right? Global wind patterns are going to go like this. Actually, where's my favorite picture? This one, okay? Now, what I like about this picture is a couple of things. One, it's showing you the differences in temperatures, okay? The colors are showing the differences in temperatures, where red would be the highest, or the hottest, right? And blue/purple would be the coolest. This is basically the same picture as everybody's most hated reference table, but just without everything else, right? It's just the winds on here, okay? The other thing you need to know is the equator, like always, acts like a mirror. Everything that's on the north side is also on the south side. So you have a northern subtropical high and a southern subtropical high. We are in the northern westerlies. Write it down. Okay? Us in New York are a part of the northern westerlies. Okay? You don't necessarily have to know all of the names or in what order, you do have to recognize that we are in the westerlies, specifically the northern westerlies. Right, because we're in the northern hemisphere, and we're about 40 degrees latitude, a little bit higher depending on where, but all of the United States is somewhere between 30 degrees and 60 degrees, so therefore our common name for the wind would be a westerly wind.
Why are they called the trade?
The trade winds. It's just the way that they name them. Okay? So, come on. All right, so we're going to watch a little bit of a video on the jet stream. Now, here's the thing with the jet stream. The currents in the ocean follow the same pattern as the jet stream. Okay? Now, that's important to know. So let's watch it. Of course, you're going to take notes because it's a little video clip. Right? And, of course, you guys can always go back and rewatch this because you now have the video. Or very soon you have the video. Commercial.
That's right. TurboTax Free Edition is free.
Choose great taste.
Commercial.
Drink like you care.
So what are jet streams? Jet streams are winds that flow high up in the atmosphere. So these are the layers of atmosphere from highest to lowest. We have exosphere, then thermosphere, mesosphere, stratosphere, and troposphere.
You already know this.
Jet streams are typically active at 6 to 11 kilometers above the surface of the Earth. And it is mostly found in the troposphere, which is the first layer of atmosphere.
You guys want me to stop it? If you need me to stop at any point, just let me know, okay? Because he goes pretty quick.
Now, jet streams can flow up to 320 kilometers per hour, and they are thousands of miles long, thousands of miles wide, and a few miles thick. Now, these strong winds flow in slim strips so that it can break off into smaller winds that can merge with other strips anywhere, anytime. That's how it will have the capability to push air masses around and affect weather patterns. You know, it literally pushes the weather pattern of any particular region. It has that much capability. So the seasons of the year, then location of low and high pressure systems, and then air temperature, all of these get affected due to when and where a jet stream travels. So if at all someone asks you, what is the reason behind the weather change or change in seasons? You can say it's primarily because of jet streams. Okay, cool. How are jet streams caused? Jet streams are caused by the temperature difference between tropical air masses and polar air masses. Now we know that tropical air is warm and polar air is cold.
Okay, before you do anything else, at the bottom of page 13 of your reference table, there's a little box in the middle of it that says air masses, okay? That's these here, these letters that are here, MT, MP, CT, CP, CA, okay? If it has the little M in front of it, that stands for maritime, and maritime basically means water, okay? If it has the C in front of it, it's talking about continental. When they're talking about continental United States, they're talking about from the East Coast to the West Coast, or in other words, only on the continent, which means on land. With me so far?
Yeah.
Okay. When you see the capital P or the capital A, they're talking about polar or Arctic, which means that they're talking about cold. Okay, so they're going to come from colder areas, either all the way from the north or all the way from the south and moving towards the equator. What's up?
So on the map where you see Antarctica, is that why there's a double A because it's so cold there?
Probably, yes. Okay. If it says T, you're expecting it to be tropical. And if it says E, I believe that stands for equator, which you don't really need to know, but you should recognize it. So usually if it's a maritime tropic, it's coming from a warmer place, which would be the equator. Does that make sense? Okay, just wanted to throw that out there so that you guys knew that.
And it is due to its relative locations. So what happens in one part of the world depends on what is happening elsewhere. After all, the atmosphere is one complete environment. It is connected with so many factors. Now, coming to the most intriguing question, where the jet stream begins. It all starts in tropics, that is around the equator. As we know, this region is warm because the sun's rays hit the Earth's surface at a higher angle at the equator. Hence, we can also call this place as a place that fuels the jet stream.
Okay, so at the equator, it's basically going to fuel the jet stream because you get almost direct sunlight there, right? 2 times out of the year, the sun is at its zenith, right? During the spring equinox and the fall equinox, right? You guys remember this? I told you everything comes back.
It's the jet stream. Now, what happens is, at the equator, the warm air rises up in the atmosphere and goes to this region between troposphere and stratosphere. From here, this warm air gets drawn towards the colder air found in North and South Pole. Notice that the warm air molecules are getting attracted towards colder ones. Now at higher altitudes, the warm air cools and sinks, drawing more and more warm air behind it. Meanwhile, the cooled air flows towards the equator, creating a simple looping mechanism. It's an endless repetition. Now the next follow-up question is, in which direction does the jet stream flow? To answer this question, we will have to answer another question, that is, in which direction does the Earth rotate? Now, this is a very tricky question. People often overcomplicate things here. Do not mix your left and right viewpoint with east and west directions. Left and right depends upon your perspective. What is left to you is a right to the person standing opposite to you. On the other hand, east and west directions are fixed. The sun rises in east regardless of your right and left direction. Therefore, the Earth rotates from west to east.
You know that.
Due to the Earth's easterly rotation, the warm air at the tropics follow the Earth's momentum and goes in the same direction and makes an angular approach from west towards north and south pole. If you want to see more of such educational content, make sure you subscribe. By doing so, you'll get in the next video.
So all I did, guys, when you're looking for people to explain things to you about it, right, it will just Google it or YouTube it. All right, so you have a subtropical jet stream, right? Subtropical is the location, right? Sometimes that subtropical jet stream drops down. Sometimes it moves up. It depends on the time of year. Same thing with the polar jet stream. Okay, back to everybody's favorite. All right, so changes in insulation are going to change pressure belts, right? So when you have that insulation or the amount of heat coming in, okay, I just put all of that up. Oh, too far. Okay, you have different times of year where the insulation is going to change. In other words, we're going to have the winter, the winds are coming from Canada or the North Pole, right? And it's going to be cold in here. Versus in the summer, a lot of times we get summer southwesterly winds coming from the south. Okay? Now, that's how we end up with seasonal changes. Okay? This is how we end up with seasonal changes. Okay, that's why we also have cold in the winter and warm in the summer because of those wind changes. Right, so if it's coming from, and they're called prevailing winds, guys. Okay, if they're coming from the equator, it's going to be warm. If they're coming from anywhere else, it's going to be cold. So do I want to end there? Let's just talk about extreme seasonal shifts really quick, guys. They're kind of cool, right? You have monsoons, and that's when in low pressure, okay, it's very, very, very wet during the summer, and high pressure is very, 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 very dry. And when I say extreme, I'm talking about ridiculously extreme. Don't worry, you'll see it. This is the difference between the dry season and the wet season in the same location. Okay? That is what's known as a dust storm.
Those are scary.
Yeah, and that's rain. What you see here
Yeah, it's from far away.
is rain from very far away. All of these darker things coming down is rain from far away. Okay? How does weather move in the United States, guys? Bottom left, top right. Just remember that. From southwest to northeast. That's why the storm that we just had came off of the coast of California and moved upwards towards us. Okay? Okay, so that's the last slide I want to do right here. Okay? Remember, ocean currents and the jet streams follow the same location. Okay? So ocean currents are created by winds, or also known as those prevailing winds, which come from the rotation of the Earth. Make sure you get this before you leave.
Bye. Dave.
Bye. So it comes from the prevailing winds, which is caused by the rotation and the Coriolis Effect, and land masses. If there is land there, it's going to get in the way of the ocean current. Okay? And of course, if you have a warm current that comes in, it's going to bring warmer weather to that location, and you're going to get a seasonal shift. This is all found on your reference table, the one that we were using for the latitude and longitude, which was pages, give me 1 second and then you're allowed to leave, on page 4 of your reference table. We'll start there tomorrow, okay? Have a good one, guys. You too.
Bye, have a good day.
All right, be good.
Bye.
Right, so this is the one I was telling you about. Okay? It looks complicated, but it's really not. And on yours, it's black and white. So it makes your life a lot easier.
See you tomorrow.
Bye, be good.
Okay, so the quiz is just what we